In this video, we're running a basic regression model in R step by step. We begin by opening R or RStudio. We have a simple data file which you can download from the link in the description from OSF. It's a CSV file, values in a text document that are separated by a comma. Let's open a data file with read.csv and the name of the file. read.csv bracket dataset.csv in quotes bracket. Because we want to use the data, we put them into an object. So we start a line with the name of the object and the equal sign. I use dataset as the name of my object. Now two things might happen. Nothing match, which is a good sign, or you get an error. If you use RStudio, nothing match means that the data file appears on the top right here. If you get an error, it's most likely about the working directory. R always looks in a specific directory on your computer, and if the dataset is not where R is looking, it complains with an error. We can tell R where the file is exactly, move the data file into the working directory, or we can change the working directory. Let's look at them one by one. To tell R where the file is exactly, you need to include the path to the file. That's a description of the directories and subdirectories. We can use an absolute path like C uses my name fun datafile.csv. For historical reasons, the slashes in R slant forward and not backward like on Windows. If you copy a file from your Windows Explorer, you have to change those slashes, or have fun with the normalize path function that's built into R. In RStudio, we can also use the graphical interface and the import data section at the top right here. Use the three dots to find your dataset, and then the rest should work without modification. The relative path is very similar, only that we tell R where the file is in relation to the working directory. To find out the working directory, we can use the command getwd or have a look here in RStudio. If your data file is just in a subdirectory, we can add this to the read.csv command, like subdirectory /dataset.csv. Now that we know where the working directory is, either because we look here in RStudio or because we use getwd, we can use our file manager, Windows Explorer, Finder, and move the dataset into the working directory. It's manual, but it works. Finally, if you want to change the working directory, you can use the command setwd, which it paths to the working directory. Or in RStudio, use the panel on the right here. Make sure you're in the Files tabs, use the three dots to navigate to the directory you want to use, and then use the cogwheel and choose Set as working directory. We can see how the working directory here has changed. Now we can use read.csv without a problem. Okay, so now we should have our data file in R. Let's run a simple regression model. The first thing we need to do is to get an overview. Hopefully you have a codebook describing the data, but I always check my variables because codebooks are not always correct. The names command is handy here. It gives a list of names in the dataset. Here we don't have many variables, so it's relatively easy to get a sense of what's there. I often use tables or the summary command to better understand the nature of each variable. With the $sign, we tell R to look for that variable in the dataset. While I won't use the table on age for analysis, using table with the variable age is an easy way to verify it's coded as a continuous variable and not as age groups or even young versus old as text strings. I can use a histogram to get a sense of the distribution if necessary. Alright, so we have the data ready and we have found the variables we want to use in the regression model. Here we use income as the outcome variable. We are interested in why some people have higher income and others have lower one. With the regression model, we can get a description of the association with education, for example. So in this case, education is the predictor variable. For a simple regression model, we have everything. For a multiple regression model, we may want to add control variables, like gender and age here. Let's look at three ways to run that regression model in R. The simplest way is the lm command that's built in. This is the Frequentist approach. Like when we imported the data, we use an object for the regression model. Let's call this M1 for model 1. So it's M1 equals, and then LM because we want a linear regression model, and brackets. That's basic R style. In the brackets we want the outcome variable first. Then we have the tilde, which is used because we're in the world of probabilities. It separates the outcome on the left from the other variables in the model. For a simple regression model, we add the predictor and then a comma, data equals, and the name of the dataset. R calculates this once we click on Run in RStudio Use Ctrl-Enter or just Enter if you're in the R console. In RStudio, the object M1 appears on the top right. To see the coefficient, we use the command summary with the model name in bracket. So summary M1 in our case. For multiple regression models, we just add more variables on the right of the formula, separating them with a plus sign. That's all. Second and third, let's look at two ways to run Bayesian models in R. There are packages that make this very easy, so there's no excuse not to. One such package is rstanarm, which takes the data and runs it in stan. If you're new to R, this might feel like a bit heavy on the sense that it downloads many packages, but it's something you only do once. The advantage is that rstanarm gets you very far and it's easy to transition to even more advanced models. The packages are free and open source and we can install them with install.packages brackets and rstanarm in the quotes. It'll take a moment to install these packages. Once everything is ready, we get the normal prompt in the console, or in RStudio that red stop symbol disappears. So we want to use a package with additional functionality. We use library and the name of the package in brackets. In this case, library rstanarm. To run the regression model is almost the same as the Frequentist model. I put this into different objects so that I can compare results later. Instead of lm, we use stan_glm. The formula is built in exactly the same way. rstanarm also provides uninformative but regularizing priors by default, so we don't have to worry about priors at this stage. The simulations take a bit longer. If you get an error, you probably have skipped the line library rstanarm. Once the 4 chains are in, we can use summary to see the coefficients. A different package is the MCMCpack. Again, we can install it, but this time there are fewer packages to install. To use the package, we use library and MCMCpack in brackets. Be careful about the spelling here. MCMC is written in capital letters, and for R this matters. In terms of the code, once again we just change the name of the function, this time to MCMCregress. The algorithm might not handle a more complex model as well as stan, but for simple models this works great. We use summary to see the coefficients. In this case, you can see how R sometimes uses scientific notation. If you're uncertain about how to use it, adding those zeros, we can change R's behavior with the option and then scipen equals 999 in brackets. This is a non-permanent change. There you go, 3 ways to run your regression model in R.